Hello mathematicians. I'd like to simplify this algebraic fraction. Well, first we'll rewrite this as a product of these factors. So we have 16 over 24, we have m squared over m cubed times n over n squared. So if we simplify this, we divide both the numerator and denominator by 8, we get 2/3. Now we're dealing with indices. We have m squared, and we'll take this m cubed in the denominator and take it up to the numerator. It becomes m to the minus 3. We'll do the same here with n. This is n to the 1 times n to the minus 2. 2/3 stays as it is. Now we're going to add indices because the base is the same. This is the rule. So now we have m to the minus 1 times, here again, we add indices. We add +1 to -2, we get -1 with the same base, so we have n to the minus 1. And now we can simplify this. 2 over 3, m to the minus 1 is 1 over m, and n to the minus 1 is also 1 over n. So in the numerator, and this is the numerator because this is m to the minus 1 over 1, this is n to the minus 1 over 1. We take it into the denominator, it becomes positive. So this is m to the 1. We don't write the index 1, and n to the power of 1. We put it all together, we have 2 over 3 mn. And let's just write this, 2 over 3 mn. And this is our solution to simplifying this. First, we decompose it into factors, integers, and we also group like terms. Then we simplify until we end up with the simplest form. Thanks for watching this video. Here's another algebraic fraction that we'd like to simplify. Again, we'll separate our terms, integer terms, and this is multiplied by x to the 5th over x squared times y cubed over y squared. We have a factor here of 3, and we have indices here, x to the 5th. This becomes x to the minus 2 when we take it into the numerator. X to the minus 2 times y to the 3rd times y to the minus 2. 3 times, we have x cubed, because we're adding indices. 5 added to -2 will give us +3 times y cubed times y to the minus 2. We add indices, we have just y. And so our solution, 3x cubed y. The simplest form of 24 x to the 5th y cubed divided by 8x squared y squared. How do we go about simplifying this? They've decomposed it, so we'll try and put it together, but before we do that, we'll gather all the integer terms so that we can see what we're doing. Here we have 8 times 5, 40 times 2 will give us 8 in the numerator, and in the denominator, well, let's work out the let's work out what we have with the terms. We have pq squared m and then rs. And so now in our denominator, we have 15 times 4 is 60, times 3 is 180. And in the denominator, we have rs q p squared. To tidy this up, we can get our 80 over 180. We'll put rs over rs. So we'll separate this again just to make it easier to see. We have p over p squared. We have q squared over q. And we have m on its own. When we simplify this, we divide by 10 first, so we have 8 over 18, and then finally we divide by 2. And we have 4 over 9. So that's our integers then. This cancels to give us 1. Now we have p to the 1 power, and this is p to the minus 2 when we take into the numerator. And here we have q squared times q to the minus 1, and we have m. This simplifies to 4 over 9. We bring it all together. This will give us p to the minus 1, which will take us into the denominator to make it p to the raised to the 1 power, or the first power. We'll have m in the numerator along with q, because this is q to minus 1, which is q to the first power, q to 1, which is q. So we have q, m. And this is our simplified version of this algebraic expression. Let me just write this so you can actually see it. 4qm over 9p. Just to recap, we cancel here to get p, because we add the index 1 to minus 2, we get minus 1, which is 1 over p. And we have p there, 1 over p here. Q to the second power times q to the minus 1, we add indices here. We end up with q to 1, which is in the numerator. And m stays as it was at the beginning. So our solution of the simplified version of this is 4qm divided by 9p. Thanks for watching this video. My name is Alistair. Bye for now. Hi, here's our polynomial positive and negative exponents, and we'd like to simplify this. So we'll go ahead and group like terms. So we have 3x to the minus 2, we have 6x to the minus 6, y to the 5th, y to the minus 2, z cube, and z to the minus 3. All that over 9x to the minus 6. We'll clear the brackets here, and y to the 6th power. All this is raised to minus 3. Now we'll try and simplify as much as we can. So we're left with 6 3s are 18, x to the minus 8th, y cubed, 5 minus 2, which is y cubed, z3 to z to the minus times z to the minus 3, that's 1. So we leave it as is. Remember, all this is raised to negative 3 power. And in the denominator we have 9 brackets x to the minus 6, x to the 6, y to the 6. Now we can cancel the 18 with 9 to give us 2. We have 2 to the minus 8 y cubed over x to the minus 6 y to the 6th power raised to the negative 3. So next we need to now clear the outer brackets, because now we're multiplying or raising everything to the power of negative 3. So we have 2 to the negative 3, x to the negative 8 times negative 3, which is 24, and y to the minus 9. This means we're also raising whatever's in the denominator to the negative 3 power. So this becomes 6 times 3 is 18, positive 18 that is, and this is y to the minus 18. And now we'll move this base of 2 with a negative exponent into the denominator. That's what we want to do. We have 2 cubed. The x to the 18 moved to the top of the x to the 24th time, x to the minus 18, which will be x to the 6th power. And y to the minus 18 moved to the numerator becomes y to the 18th power times y to the minus 9 will give us y to the positive 9. Now 2 to the 3 evaluates or simplifies to 8. And that's our simplified form of this polynomial with both positive and negative exponents. Simplifies to x to the 6th power times y to the 9th power over 8. Thanks for watching this video. My name is Alistair. Please like, follow or subscribe for more videos like this. Bye for now. And here's our next polynomial with negative exponents. Now we'll go ahead and clear the brackets here, and then we can do a bit of grouping. So everything gets raised to the power of negative 2. So we got a to the negative 2. Now this is b cubed, so this becomes b to the minus 6. And we have this as it is. And 2a to the minus 4 in the denominator. B to 0 is 1, so we're still left with 2a to the minus 4. Now we'll group like terms and then simplify. So we have a to the 1, which is a, with a to the minus 2. We have b we'll just move the a to the minus 4 to the numerator, and that becomes a to the 4th power. So we can group all the a's just in this first step, or second step. Next we have the b's, so we have b to the minus 6 and b to minus 3. And now in the denominator we'll bring the 3 to the minus 2 down to the denominator, and that becomes 3 squared, and we're left with the coefficient of this, which is 2. And now we can evaluate our numerator. We have a to the 1 times a to the 4th, which is a to the 5th, times a to the minus 2 will give us a to the 3rd, or a cube. We have b to the minus 6 and b to the minus 3. That gives us b to the minus 9. And in the denominator, this becomes 18. And to make sure that we simplify this, we have positive exponents, powers, or indices, whichever word you prefer. We have a cube. We bring b to the minus 9 to the denominator, it becomes b to the 9th power. And that's it. We've reduced what we're given here with negative exponents to something simple with positive exponents, powers, or indices. Thanks for watching this video. My name is Alistair. Please like, follow, or subscribe for more videos like this. Bye for now. Hi, we have this polynomial, algebraic fraction, and we need to simplify this. We'll use the law of indices to manipulate negative and also positive indices. So let's get started. So we have 4 to start with. Anything we move from the denominator with a negative index move to the numerator becomes positive, and vice versa. So we have x to the minus 5. We'll move this x to the minus 5 to the numerator to become x to the 5th power. Now we'll group also together with x. We have 3x cubed. All of these are multiplied by each other. We don't write the multiplication sign in algebra. We just leave it as written here. Now we look at the y's. We have in the numerator y to the minus 3, y to the minus 2. And now in the denominator we have 6y cubed left. Now we'll multiply the 4 by the 3 to give us 12. This cancels with this to get x to the 0, which we do know is 1. Now we have x cubed here left. Now we have y to the minus 5 divided by 6y cubed. So this cancels with this to give us 2. This is 1. So we have 2x cubed. Now we'll move y to the minus 5 to the denominator. The aim is to have, or to reduce this to positive indices or exponents, whichever word you prefer to use. So we move this y to the minus 5 to the denominator, and it becomes y to the 8th. And that's it for this problem. Suppose we have this fraction and we wanted to simplify it or find the value of it, and we didn't have a calculator. Well, here's a quick way of manipulating both positive and negative indices without the use of a calculator. We'll try and keep everything positive, so we'll have a 2 to the third power there. And in the denominator, we'll still have 4 squared. But we'll move the 3 raised to the negative 2 in the denominator, and that becomes 3 squared. And also the 5 raised to negative 1, that becomes just 5. And instead of having this as a negative, with a negative index in the denominator, we'll move this to the numerator, and it becomes 0.3 squared. So just to recap, we're moving the negative indices into the denominator and they become positive, and if we have any negative indices in the denominator and we move it to the numerator, it becomes positive. So we have 3 to the negative 2 becomes 3 squared, 5 to the minus 1 becomes 5, or 5 to the 1, first power, same thing, and 0.3 to negative 2 in the denominator becomes 0.3 squared in the numerator. And now we can go ahead and simplify this. This is 2 to the third power is 8. Now this 0.3 squared is 0.09. And we have 16, 4 squared, we have 9, and we have 5. Now let's rewrite that here. We have 8 in the numerator, 0.09 over 16 times 9 times 5. Now 16 5s are 80, 80 times 9, we have 720 in the denominator. And 8 times 0.09 will give us 0.72. And further to this, 0.72 is the same as 72 over 100, and that's in the numerator. Now it's 720 over 1 in the denominator. We make that 1 over 720 and multiply it by 72 over 100. Now we can cancel or simplify in this direction. This gives us 10. And now we're left with 1 over 100 times 10, which is 1 over 1,000. Now there are 2 ways we can express this result. Well, 3 ways. We have 1,000th. We could also express it as 0.001, or in standard form as 1 times 10 to the minus 3. So all 3 of these, this, this, and this, are equivalent. Thanks for watching this video. My name is Alistair. Any questions are welcome. Please like, follow, and subscribe for more videos like this. Bye for now. Hi, this is Harris Maths. Solve this equation. Well, if we multiply both sides by 10, we can get rid of the 2 denominators on both sides. So we'll write it as 10 brackets 1 add a, and this is over 2 is equal to 10 into 1 add 3a and the 3a is over 5. Now this cancels out to give us 5 into 1 add a. And we clear the brackets here, we have 10. 10 times 3 is 30. 30a over 6, over 5, sorry, will give us 6a. And now we clear the brackets here to give us 5 add 5a is equal to 10 add 6a. Next, if we add negative 10 to both sides, we'll get rid of the 10 here and it'll be on this side, so we have 5 minus 10. And if we add negative 5 to both sides, we get rid of it from the left hand side and it becomes 6a minus 5a. If we evaluate each side and swap sides, this becomes a, and this negative 5. And this is your solution. I'll leave this as an exercise for the audience out there. And that's it. My name is Alistair. Thanks for watching this video. Any questions, comments, requests are all welcome. Don't forget to follow or subscribe for more videos like this. My name is Alistair. Again, bye for now.